Hello everyone. In this session, let's talk about packing and padding in structures. I clearly mentioned that this is not for your university exams. For those who want extra content and those who want to gain knowledge or those who are preparing for competitive exams, for you, this is important. Okay, others can just understand what is this concept and where it is helpful. Okay. So now let us see what is meant by padding and what is meant by packing. First, talk about padding. Is the term new to us? What is padding? Did we use it anywhere in C programming? Yes, of course. If you just recollect, if you see while we practiced the syntax of printf, okay, so here I have declared a as an integer and I have initialized it with 123. Okay, and here I am printing it as percentile 8d. Okay, what does it mean? I have reserved 8 spaces for my printf. Okay, out of that 8, I have only 3 digits. So this printf will reserve 8 spaces. One second, let me take the pen. Yeah. So I have reserved 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm expecting at max 8 numbers. The length of this digit can be 8. So I have reserved 8 spaces for this. Out of that, how many digits do I have? 123. Okay. So since by default it is okay, so 123. So initially I'll get 5 spaces and then 123 gets displayed. Okay. So here what is being added, what is being padded? Spaces are being padded here. Out of 8, I have only 3 digits. What about the rest of the digits? That is just empty. Space is being padded here. Okay, I'll just execute and show you clearly so that you will get an idea. This concept we have already worked out. So you just try to recollect this. Okay, yeah. Here, what can you see? You can see a space here. 1, 2, 3, 4, 5 spaces you can see, and then 1, 2, 3 is getting displayed. Okay, so this we call as justification, left justified and right justified. Suppose if I give a minus sign here, I think now you will remember. So if I give a minus sign, it will be left justified. Though I have reserved 8 spaces, the number will come in the beginning, left justification. It will start from the left hand side. If I didn't give any sign, by default, it is starting with, it is right justified. So if I won't give anything here, that means it will be treated as plus and it is right justified. So only you can see that the number is displayed at the right extreme. We have reserved 8 spaces. Out of that, 5 are spaces and 1, 2, 3 is getting displayed. What is this? Space is being padded in front of this 123 to make it a length of 8 digits. This is what meant by padding. Okay. So now let us switch to our concept. Yeah. So here, what is padding in structures? Okay. So already we have seen an example, right? So here we need to talk about one concept called as CPU cycles. Okay. I'm just trying to take a pen. Okay. Yeah. Oh, sorry. Yeah. So let's talk about what is meant by a CPU cycle. So why padding will happen and when it will happen. Okay. So before knowing that, let us see a CPU cycle. Okay. So whenever you are giving an instruction to the machine, what will happen? Okay. You have already saved it. And when you are executing, what will happen? It will be fetched from the memory. Okay. So first fetch from memory. In one CPU cycle, what will happen is first it will fetch for the corresponding instruction. Okay. And then what will happen? It will decode from machine language. from user defined language to machine language, high level language to machine language conversion will happen, and then it will execute. So these all are part of one CPU cycle. So that means retrieving the data that is stored from the memory and then decoding the instruction and then executing. So this whole thing will happen in one CPU cycle. Okay, so what is the purpose of this CPU cycle? The speed of your CPU cycle, the speed of your CPU is determined by how efficiently you are utilizing these CPU cycles. Okay. So now in one CPU cycle, how much amount of information can be read? Okay. So in one CPU cycle, it can read 1 word of data. What is meant by 1 word? Is it 1 byte? No, it is not the same. Okay. So in one CPU cycle, 1 word can be either 4 bytes or it can be 8 bytes. So if you are using a 32-bit machine, okay, 1 word is 4 bytes in case of a 32-bit machine. If you are using a 64-bit machine, 1 word is of 8 bytes. 32 by 8 is 4, 64 by 8 is 8. So that means in one CPU cycle, it is not reading one single byte, but it will read 4 bytes at a time. Okay. So depending upon the compiler that we are using and depending upon the machine that we are using, either it can read 4 bytes at a time or 8 bytes at a time. Why it should do so? Because to save the number of CPU cycles, it want to save the number of CPU cycles as well as the time. Okay. Suppose if you have very short time. Okay. So in that time, you have 3-4 tasks to complete. What will you do? Parallelly, you will try to complete all that. One side, you will text your friend on the other side, you will debug your code. On the other hand, you will try to note down the results or you try to respond to the attendance. Parallelly, you will do multiple tasks, right? Why you are doing so? In order to save the time. Within a stipulated amount of time, you have n number of tasks to do. In the same way, our CPU also has n number of tasks to do. It want to save the CPU time. So how it can save is by reading more number of bytes in 1 word. Okay. So for that, what it will do is, suppose if the data is short, just in the example what we have seen. So in the same case, suppose if the data is short, it doesn't has 4 bytes of data. Okay. Or it let us see the data that it has to read or in a structure. So as we have seen, let's take 2 characters. And let me take an integer. Okay. Okay. So for integer, 4 bytes is required. For each of this character, 1 byte is required. So total of 6 bytes. So now S takes 1 byte, Y takes another 1 byte, and another 4 bytes are required for the variable A. So now let us assume that our CPU cycle can read 4 bytes. The size of 1 word is 4 bytes, let us say suppose. So then what will happen? So it can read up to the first 4 bytes at a time. So that means it will read this S, it will read this Y, and 2 bytes of A. 2 bytes of A it can read. To read the other 2 bytes, again it has to use one more CPU cycle. In the first CPU cycle, it is accessing memory once, and it has read the values of S and Y, and only 2 bytes of A it has read. Okay. It has accessed only 2 bytes of A. So then again, what will happen in the second CPU cycle? Okay. So this second CPU cycle is also capable of reading 4 bytes at a time, but we have only 2 bytes for reading. That is the remaining 2 bytes of A. So now in order to read this A, how many bytes have we used? Just to read the value of A, how many CPU cycles we have used? 1 and 2. So just to read one value, we are wasting 2 CPU cycles. Okay. So what can be done is, in order to utilize this time, okay, in order to utilize this time, how the data will be stored, in order to save the CPU cycles, padding will be applied. So that means S will be stored, Y will be stored, followed by this 2 empty spaces will be padded off, and then another 4 bytes for A. Okay, so here these 2 bytes is just empty space. So here I have read 2 characters and here I have an empty space. So in one CPU cycle, I can read this data, and in the second CPU cycle, I can read A. But this time, how many cycles am I using to read the value of A? Only one cycle. But in the earlier case, if I am not using padding, how many cycles am I using to read the value of A? I'm using 2 CPU cycles. Okay, so in order to save the number of cycles, CPU cycles, in order to make a faster processing or parallel processing, our CPU follows this padding concept. Okay, so internally, though we have given like this, we are assuming that it is stored like this, but actually internally, it has stored like this. So only, instead of giving only the size 6, how much it is giving? 1, 2, 3, 4, 5, 6, 7, 8 bytes it will give you. If you want to know the size of this structure, it will, when you execute, it will give you a size of 8. I'll just come back to the execution part and I'll clarify on this. So earlier we have executed, right? Yeah. Here. So I have taken char name of 8, and then I have taken section and roll number. What is the size of this structure? As per our knowledge, okay, so we are assuming that this character string will take 8 bytes. And then 1 byte for this character, and for roll number, another 4 bytes. Altogether, we are assuming 13 bytes. But as per the concept of padding, what will happen? So one word size we have taken as 4 bytes. So 1, 2, 3, 4, 5, 6, 7, 8. So all these 8 bytes are for 4 plus 4. Yeah. So these 8 bytes are for name. Okay. Using 2 CPU cycles, this name can be read because it is long. And then char section, it just takes only 1 byte. And then roll number, another 1 more byte. Roll number, 4 more bytes. So what will happen? Half of the part of roll number, it doesn't want to access in one cycle and half in another cycle. So what will happen is it will pad another 3 spaces in order to make this name also as size 4. This is for section. Okay. And followed by roll number, another 4 bytes. Now tell me altogether how much space. So here this is 8. 8 plus 4, 12. 12 plus 4, a total of 16 bytes. So this much will be allocated by the compiler. Okay. Are you getting why it is happening so? Name requires 8 bytes. Okay. We have assumed the size of CPU cycle or size of one word as 4 bytes. One word equal to 4 bytes. So that means in one CPU cycle, our CPU can read 4 bytes at a time. So name is of size 8 bytes. So this is one word. This is the second word. Okay. So it requires 2 CPU cycles. Fine. The length of name is long. So Fine. CPU cycles are not wasted here. So two cycles is also okay. But here coming to the section, what is the size of section? It is just 1 byte. And followed by immediately, if I store this roll number also, what will happen? 3 bytes will be read one time. And for one more byte, we have to use one more CPU cycle. Are you getting? I will just draw this part once. Name I am not drawing. From the section, if you see, for section, it requires 1 byte. And for roll number, another 4 bytes for roll number. 1, 2, 3, 4. Okay, so let us assume only this part. Okay, so then in one CPU cycle, it can read 4 bytes. So that means this whole thing is for roll number, the 4 bytes. But out of the 4, these 3 bytes will be read in one CPU cycle and one more byte which is part of roll number will be read in the second CPU cycle. Okay. So in that, what it is doing, we have only content for 1 byte. That means the first CPU cycle is not utilized to its full extent. Part of its time is getting wasted because it doesn't has any data here. Okay, no need of fetching, no need of decoding, no need of doing anything. Sorry, not here. Here, in the remaining part. So though we have only 1 byte to read, the remaining 3 bytes will be empty. Okay, so here it has nothing to do. So since though it is capable of reading 4 bytes at a time, how much it is reading? Only 1 byte. So this we call as wasting of CPU cycles, which affects the performance of the CPU, which affects the performance of the system. We don't want to waste the CPU cycles. For that, what the system will do is, instead of using 2 cycles to access one single variable, which is roll number, so what it will do is it will pad here. So section is taking only 1 character. Since the size of word is 4 bytes, it will pad another 3 spaces and followed by it will store the roll number. So now instead of 13 bytes, it is taking 16 bytes. So this is the concept of padding. Now let's execute this and see. I think I have used the pragma command. 1 second. Yeah, your pragma is there. Yes, so here you can see the memory allocated for the structure variable S1 is 16 bytes. But actually what we have thought, it should be 13 bytes theoretically. But the CPU is giving 16 bytes because here it is performing parallel processing and it doesn't want to waste the CPU cycles. So how do we get that 13? So here, if the CPU doesn't want to use the concept of padding, okay? If you doesn't want CPU to use the concept of padding, what you can do is, you can say that use packing instead. How can you tell? So you can tell that using the pragma command. Okay, so here this is a preprocessor directive, pragma. So this command will help you to on or off certain features. Okay, so what I want to on the packing feature. So I am telling on the packing. So that means instead of padding the spaces, pack everything together. Let the CPU cycles get wasted. But I want to utilize my memory. I want only 13 bytes. So in this case, what will happen is, how we thought in the same manner, it will be stored. 8 bytes will be for name. For name, it will take 8 bytes. And another 1 byte for section. And then another 4 bytes for roll number. 4 plus 1, 5, 5 plus 8, 13. So a memory space of 13 bytes. But to access the roll number, it takes again 2 CPU cycles. Though the CPU cycles are getting wasted, we want the memory to be used in an efficient manner. Okay, so I'm saying pragma pack. So you pack everything into a single one. So don't use padding. You pack everything into a single, we are saying. So here, immediately after this one, no space is being padded, but the space for roll number will be allocated. The number of bytes required for the roll number. So 1, 2, 3 bytes and one more. Okay. So this whole thing will become one and the rest of the part will become one. So this is what the usage of the pragma command, pragma pack of one. That is the syntax that we need to follow. Let's see the execution. If we use the pragma command, how does it change? Yeah. So here you can see I have used the pragma command. So now instead of 16, only 13 bytes should be my output. Let's see whether we get it or not. Okay. Previously I have commented it. Let me enable it. Yeah. So I have used the preprocessor directive hash pragma followed by pack of 1. Now let's compile this. Whenever we make any changes, always it is recommended to compile in order to get a fresh objective file with the modifications. Yes. So now you can see memory allocated for S1 is 13. So now it is up to you whether to waste the CPU cycles or to waste the memory. Suppose if memory is not a constraint for you, so you have sufficient amount of memory. So in that case, what can you do? So you can go for padding concept where the number of CPU cycles will be saved and in less number of cycles, you can read more amount of data. Okay. No, CPU cycles are not important. Performance or speed is not a matter of fact, but I want the memory to be utilized efficiently. So in that case, if you are giving or if you are stressing on the memory part, it is better to go with this packing concept. So where you can use hash pragma, and here the CPU cycles will be wasted, but memory will not be wasted. Hope you followed the content. If you have any queries, please let me know in the comment section and do follow and share. Share the lectures to all those who require this. Thank you. And if you have any suggestions also, please leave a comment. Thank you.